Alright. Hello everybody, this is Juan for second class. Clark. This is not my actual rank, this is the rank I have for the virtual training center. And this is M140.01, launch a water rocket. So as your instructor would have informed you already, this is an alternative way to launch the rocket. This is not the way in the IG, this is just an alternative way you can use any way you want. Or you're watching this video because you're unable to launch the rocket. So let's quickly go over what you're looking here. So obviously, this is the rocket before it's been launched. And the reason why this is important is this is actually demonstrating Newton's first law, which is any object in motion or at rest will stay in motion or at rest unless an applied force is acted upon it. Because right now this object is at rest. Nothing's acting on it except for gravity, and you don't see it, but the ground is actually applying a force towards it, which is causing the object not to fall to the ground. So in a moment, we're going to see the first launch, which is without water. There you go. So if you noticed, when the actual rocket was launched, it went up. Went up, right? Which is demonstrating Newton's second law, because the object was at rest. Now it's in motion because an applied force coming from the actual launching of the rocket overrided the gravity. So because the forces are no longer equal, it's moving upwards. But as it goes up, that initial launch loses power, and eventually it no longer has that applied force. So right before it falls down, there's no force. The forces acting on it are equal. The applied force, the gravity is applying on it, and just for a slight moment, the object stops moving before it begins to fall down. Because with no applied force moving upward, and the only force acting on the object is gravity, it's going to begin to accelerate downward. And as it goes close to the Earth, it begins to move faster and faster. And eventually, the object falls and hits the ground. At that point, the object hits the ground, and once again, it's representing Newton's first law, which is an object at rest will stay at rest, because now there's no longer an applied force. It's just the force from the ground and the force from gravity, and now it cancels each other out. In regard to Newton's third law, comes from the actual launching of the rocket. Which is not here, but where is it? There. Right there from the launch. So, it's already airborne, but the launch is a thrust. It's a thrust upwards, which comes from the actual launch and the actual firepower, which actually hits the ground. And then the equal force is the object being thrust forward, the rocket being thrusted forward. So when rockets are launched, the actual explosion is going towards the ground. And the reaction from that the rocket receives, that reaction thrusts it forward. And it is equal reaction. So in this case, the force from the actual launch was enough for it to actually be airborne. But in an actual situation with NASA and their space rockets, the force has to be a lot larger, so the equal reaction force is just as large, which is enough to make it to space. And once again, this is the first launch without water. So now we're going to look at the second launch with water. Okay. So a couple things about the actual launch with water. A lot faster. It was about a second long. And if you look at the original launch without water, it's 3 seconds long, right? So if you pay attention, the rocket traveled a third faster. That's because the original rocket did not have any mass. The mass was 0. This time, we added a third of what the water bottle could hold. And scientifically, this only applies to water, but 1 liter of water equals 1 grams of water. So if it's a third, if the bottle is filled up a third way with water, we can actually say it's actually filled up a third way of mass. It's a third of the mass, right? So because of that, it traveled a lot, it's accelerated a lot faster towards the ground. Because if you look at the formula, force equals mass times acceleration. Because the mass was larger, the acceleration was larger. So in this case, if we go back to the second law, it also states that every applied force, any applied force applied to an object, the direction of the actual applied force will have the object move in that direction, which can be noticed from the actual launching of the rocket both times. Because the applied force went upward, the actual rocket went upward. And again, in regards to Newton's third law, every force has an equal reaction. So because of the mass, the actual force coming downwards from the rocket was stronger because it had more mass. So you'll notice this time when it hit the ground, it bounced around a lot more. Or not as much as I thought. But typically it does. If it was extremely light without any mass, it would have just hit the ground and stopped. But because the actual mass of the rocket was increased, it was heavier. So when it hit the ground, it was a lot stronger. Thus, it can also be noticed from the loud thump of the actual rocket hitting the ground. That's because the force hitting the ground was stronger. So once again, this was the rocket launch from the object actually at rest before the launch. It was the same rest in both times. Launching the rocket with and without water. And throughout the entire launch, we were able to observe Newton's 3 laws regarding motion.